Assalamualaikum everyone. So we are going to continue our lecture on metal cutting 2. Today we are going to cover 3 topics which are turning, drilling and also milling. So what is machining? So machining is basically is material removal process where sharp tool is used to mechanically cut away the material so that we will get the desired part geometry. So the most common application is by using the metal parts, and this process is most versatile among all the manufacturing process because you can get a certain variety of shape and geometry, and also you will be able to get high precision and accuracy dimensions. So in casting we can also produce a variety of shape, but it is very difficult for us to get the accurate dimensions and also good surface finish. So that's why machining is usually is the final touch after the other process. There will be two classification of the machine part. One is rotational, which is cylindrical or disc-like shape. So this one usually used in the turning process. And we have non-rotational, which is block-like or plate-like, mostly used in the milling, drilling process. Okay. In generating the characteristic in the part geometry, there are two factors that that make this possible. One is true relative motion between tools and work part. So this one we call as generating process, where part geometry determined by the trajectory of the cutting tool. So it depends on the movement of the cutting tool to get the shape on the workpiece. And another one is shape of the cutting tool, or we can call it forming process, where the part geometry is created by the shape of the cutting tool. So here are some examples for the generating the shape. So for example, A is straightening, so that the movement of the tool will determine the straightness of the workpiece. And then we have taper turning. So taper turning also it depends on the movement of the tool to get the angle shape. Okay, and then contour turning, so movement of tools that create the contour on the workpiece. And we also have plane milling and also profile milling. So this one is everything is depend on the movement of the tool in order to get the shape that we want. So for forming to create the shape, here are the example. A is the form turning, where the shape on the workpiece is depend on the form tool. The second one is drilling. So if you can see the drilling, the diameter of the hole created is depend on the tool bit of the cutting tool. And last one is the broaching. So broaching is dependent on the shape of the broach tool that create the shape on the workpiece. Apart from that, there are also combination of forming and generating. The example is thread cutting on a lathe. So if you can see, the shape of the thread is dependent on the shape of the tool, but the length of the thread is dependent on the movement of the tool along the workpiece. And another one is slot milling. So the shape of the mill part is determined by the shape of the tools, but due to the movement of the tool along the side, so all the parts can be created. Okay, so that's one are the example on forming and generating process. Let us go to the first machining process, which is turning. So turning is a single point cutting to remove the material from a rotating workpiece to generate a cylindrical shape. So this one is performed on a machine tool called a lathe. So variation of cutting tool of turning performed on a lathe are like facing, contour turning, chamfering, cut off and threading. Now let us see the component that have on the turning operation. So the first one is the parameters in turning process can be given by n, which is the revolution per RPM, revolution per minute. Okay, so this one is usually related to the cutting speed of the workpiece. And then we have feed rate, so the movement of the tool, how fast is the tool movement. And then this is the cutting speed, how fast the workpiece rotating. Okay, and then this is D, which is the depth of cut, how much the tool coming inside and cut the depth of the workpiece. So apart from that, you have to know that there is the initial, what is the initial diameter before the machining process, and final dimension after the machining process, and also how long is the cutting process take place. Okay, so here are some analysis of turning operation and cutting condition in turning. So here the first equation is the rotational speed, which is revolution per minute, or you can usually know as RPM. Okay, so when the this equation is given, if you can to ensure you that you can change from RPM to cutting speed meter per minute. Okay, so you can use this equation for the conversion. Okay, so N is in RPM and V is the meter per minute over pi d naught. So pi d naught is the initial diameter of the workpiece. Okay, so apart from that, you can also find the final diameter of the workpiece through this equation, which is d naught minus 2d. Why 2d? Okay, d is the depth of cut, right? So when you see from this view, so if you start the machining, let's say this is the diameter initial, this is diameter final, so there are two sides of d going inside, right? So that's why they have to minus 2d. Okay, so that's the df equal to d naught minus 2d. So for feed rate, if the value given is f value, which is in mm per revolution, you will have to convert it to mm per minute if the calculation needs you to use this unit. Okay, so what you have to do is just multiply it with the n value, the rpm here, the rpm here. Okay, so then you will get the feed rate value. To calculate the time of machining, it is Tm equal to L over Fr. L is the length of the cylindrical work part being machined. Okay, so how long the machining take part. Okay, so the L value. So if you can see, you can refer back to the diagram previously so that you will know what is L. Okay, so then we can also use the direct compositional of the machine time by using equation below, which is Tm equal pi d naught L over Fv. Okay, material removal rate for turning is calculated by using V times F times D. So then you will be able to get the value for RMR. So now let's see a problem to be solved. In a production turning operation, the cylindrical workpiece is 375 mm long, 150 mm in diameter. Feed equal to 0.3 mm per revolution and depth of cut equal to 4.0 mm. What cutting speed must be used to achieve a machining time of 5.0 minute? So this one, we have to refer to the equation for time of machining, Tm. Okay, So since all the value is given, then you can use this equation Tm equal to pi d naught L over Vf. Okay, so d naught is given, L is given, and then V is also given, and V is not given. You have to find the V. F is given and Tm also is given. So what you have to do is just rearrange the equation V and make it into V at the front. So then you just put inside all the value inside the equation, then you will get the answer. So here is another example on the turning. So it wants you to calculate the cutting speed, material removal rate, power required, and cutting force. So for the first one, if you read the question, they didn't give you the V which you have to find. So they only give you the N value. So if you use the N equation for the rotational speed, N equal to V over pi d naught. So then you will be you rearrange the equation and you will be able to get the first answer, which here is given as 26.17 mm per minute. So for the second one, you have to calculate the RMR. RMR is VFD. So V is already given. V is given in terms of 200 mm per minute. So you have to convert it to get same uh, the same unit, and then D also is given. So once you put it inside the equation, so then you calculate and you will get the answer. Okay, so for the third one, it is power required. So if you can remember from the previous one, so PU is inside here, since power of cutting is equal to FV, right? So F is not given, so you can use the uh, PG equal to PC over RMR. Okay, PU, sorry, PU equal to PC over RMR. So the PC you can get by PU times the RMR. So PU here is given in the table for stainless steel is 2.8 joule per mm power cube. So then when you calculate, you will get this value, and then cutting force is if you can remember, PC equal to FV, right? So then you will get you can get the F value from this equation. So here is the close-up view of turning operation on steel using a titanium nitride coated carbide cutting insert. Okay, so this is the photo courtesy of the Kennametal Inc. Now, let's see some operation related to the turning. Okay, so A is showing the facing process. Okay, so facing process is usually the initial process before the real turning process is performed. Facing is the purpose of facing is usually to remove the outer layer of the work material, so that a straight workpiece can be achieved before the machining take place. The second one is taper turning. Taper turning is used when you want to create an angle shape on the workpiece. And the C is contour turning. Contour turning is a turning where the movement of the tool will create the shape with not angle, with the contour on it. Okay, so that's the operation for the contour turning. Another example is form turning. So form turning is achieved by using the form tool. Okay, so but you can perform it under the turning operation. So chamfer turning. So chamfer operation is to remove and make it a 45-degree angle on the sharp edges of the workpiece. And last one is the cut off. cut off is usually the last, or maybe the process where you want to remove the final product from the initial material. Okay, so then you will get the final product that you already produced. Other operation that can be done in the turning process is threading. So threading, when you want to crack the thread on the metal. Okay, so you can use the thread tool and then perform the turning on it. And then we also have boring process. Boring process is by creating the hole inside the area of the workpiece. So this one we are going to look further later. And then we also have, you can also perform drilling in the workpiece using the turning process. And last one is knurling. Knurling is creating the crosshatch surface on this area. Okay, so there's a special tool for knurling process. So in turning process, we need machine to perform the machining process, right? So engine lathe is the machine tool used for the turning process. So here are some components on the lathe machine. Okay, so the first one is headstock. Headstock is where the it contains the drive unit, where it will have the motor to rotate the spindle so that it can rotate the workpiece. Okay, so and then the cutting tool is hold on the tool post fastened to the cross slide, which is assembled to the carriage. And then we have carriage. Carriage is designed to slide a long way of the lathe so that we will be able to move the tool to the front and then going back. Okay, and then we have tailstock. Tailstock is the center to a mount and or to the support to the other end of the workpiece. If you use a long workpiece, so then you can use the tailstock. And then we have way. The way are built into the bed of the lathe, providing a rigid frame for the machine tool. So this one is used to make sure that the tool post can slide, okay, on the machine. And then we have the carriage is driven by the lead screw. So lead screw is what make the carriage can move from front to the back. Okay, so that's the component of the engine lathe. Now let's see how the material is being hauled on the lathe machine. So there are four example on the most common one that use to hold the workpiece in the on the lathe machine. Okay, so the first one is holding the work between centers. So the centers consists of the dock, which is the device to clamp the work, which driven by the dock plate. Okay, so if you put the work material on the inside here on the dock and also dock plate, so and then you push the work material inside, so it will create the friction in between the cutting tool and also the dock here, so then it can place the workpiece inside the dock and dock plate. Okay, so the B is the most common one, which is by between the chuck. Okay, so chuck also have different type of chuck. So but here is showing the 3-jaw chuck. We can this one is depend on the diameter of the work material. So if I'm not mistaken, for 3-jaw chuck it's around 50 mm to 100 mm workpiece can hold the 3-jaw. The 3-jaw can hold up to 50 to 100 mm diameter. Okay, other than that you can also use 4-jaw. Okay, so this one is depend on the type of the workpiece and the dimension of the work part that we use. So this one can be moved out in, and inside. Okay, so this one is the one that you use in the workshop. Okay, apart from that, we also have the collet. Okay, so collet is quite the same with the dog, only the type of the holder is different. Okay, so this is a collet. So what you have to do is just you have to push inside here so that the friction will um, hold the workpiece together. And we also have the faceplate. So faceplate is attached to the spindle, so then and then this one you can open and close it. Okay, so let us go to the boring process. So what's the difference between boring and turning? So boring is performed on the inside diameter of the existing hole. So you cannot start the boring process by using the boring tool itself. You have to create the hole inside um, the work material first, and then you can enlarge the hole by using the boring process. Okay, so turning is performed on the outside diameter of the existing cylinder. Okay, so for the boring machine, you can perform it horizontally or vertically. So for vertical, for the horizontal, it is similar to the turning, but it performed inside the workpiece. So here are the vertical and also the horizontal boring process. So this is the vertical. Okay, so the tool is hold vertically, and this one horizontal. So so then this workpiece, this tool can enlarge the diameter inside here. And for the boring process here, for horizontal, it goes like this, and then it can enlarge the hole inside.